So, you want to learn GTK in Haskell. Wow! That's not a problem because we have gi-gtk or Haskell GI, and it's a very good library to make graphical user interfaces, but it has a little problem. Its documentation is basically just a tutorial on how to translate the C API to Haskell GI. Sure, you have some examples here in the examples folder, but for me the documentation is what matters, and this just isn't enough. I need to at least know how to search for the C API or the GTK docs. And when I first started making GTK apps, it was very, very hard, especially for this overloaded labels. They're simple, but they're so complex, especially to search for it. So today, I intend to teach you how you can search yourself through the C API and Haskell docs to translate it to Haskell GI. So to do it, I'm gonna translate this app from the GTK docs available on this link. We're basically going to make this window with button 1, button 2, and quit. So let's get started. And to follow this tutorial, I'm assuming you know the basics of Cabal. It's really easy, just install Cabal and type Cabal init. It should be very self-explanatory. Like, oh yeah, you want to do backups? Yes, why not? And just go with the defaults and it should be okay. Now, the important part is after you Cabal init, go to your Cabal file and in build depends, add these 3 lines. Each one's a different library. gi-gtk, Haskell GIBase, and gi-gio. You need those 3. If you include just gi-gtk, you will be very limited in what you can do. So let's start. Open your main file. So okay, here we have a main function. Let me see if I can increase this. Declaring variables isn't important for us because we are coding Haskell, right? The first important line is this app line. It calls GTK application new. If you look in the documentation of Haskell GI, you'll see here, you just remove GTK from the beginning and convert it to a camel case. GTK application new would be application new. But first we gotta import Haskell GI, right? Or gi-gtk. So import gi-gtk. Okay. And I recommend you to import this as qualified. It's just a standard and it helps, like, the name of the function is GTK application new. Here, with the qualified import, you can do gtk.application new. It just looks a lot more similar. Let's just create our main function. It's gonna return an IO empty tuple as usual. And let's make it a do block because it looks prettier. So we have to create an app variable from this function. So app and GTK application new. And now, what this function takes. Let's search on Google. Here you can go to hugo.haskell.org and search for the function you're looking for. For me, it's this one from Haskell GI package. And it takes a maybe text and a list of application flags and returns me a monad.io of application. Okay, so maybe text is also known as application ID, and it's easy to see the application ID is this org.gtk.example. So just this, okay? And now application flags. What are the available application flags? Let's see. You just take application flags, go to Google, search for it, and here, gi-gio. Let's see. Here it takes application default flags. Let's see, here. Application flags, default flags. Nice. So in the list, we're gonna put this. But application default flags is in gi.gio.flags. So we gotta import gi.gio. Oh, wait, here. gi.gio, yeah, okay. Now we have application flags, default flags. And let's add a return empty tuple just to get rid of the error. And okay, the only thing that's wrong here is this string. If you see, it expects a text, but we are giving it a string. Text and strings are very similar data structures, but they're different. We just have to convert the string to text. There are some functions that convert it, but for me, the easiest way is just to use overloaded strings. It is a Haskell language pragma. Language pragmas are just a way to extend the Haskell language. You just go like this. Language overloaded strings. Nice. And now it just automatically converts string to texts. Okay, let's go to the next step. It's g-signal connect. So it's a signal called activate. If you look at the README, it says for signals you want to use onType signal name. So it's a signal in an application called activate. So it's gonna be on application activate, right? On application activate, and let's search on Google. Here it is. It takes an application, which is the A, right? Here is application. And this is a very strange thing called implicit parameter. Just ignore it. You just gotta give it a function that returns a application active callback. Oh, and let's see in which package it is. gi.gio, okay, we already imported it. It takes the application, our app, and our activate function. Like here, we are giving it activate. Activate here is this function activate. So activate. And activate also takes the app as an argument here, right? GTK application app. Let's just add the type signature for now. It takes an application, in our case it's a GTK application, and returns a application active callback. No, application activate callback, okay. Oh, we take an app and then the find for now. Okay, and now we get an error saying that app, this isn't actually an app, it's a maybe GTK application. We don't want a maybe GTK application, we want just the application without the maybe. What we can do is just go let just application equals app. And here, this should work, but it doesn't look that pretty, so I'm gonna refactor it. To refactor it, I'm gonna use a case expression. So, wait, let's delete this, and here, app. Okay, we're gonna take the result of this function and pass it to a lambda expression. But it's not a standard lambda expression. It's a LambdaCase expression. Let's go. If this returns nothing, we return exit failure. And we got import system.exit, I think. Yeah. And if it returns just x, we return x. But to use a lambda case like this, this is a backslash, right? Like this. But it just gets prettier here in Emacs. Okay, to use a lambda case, we gotta use, let's see, lambda case, yeah, okay. Now this is allowed. Let's see, here, status, application run. Okay, so it probably is application run from gi.gio. And let's search Google again. Here, application run from gi.gio. It takes the application and argv and returns a int32. So it takes the app and argv. Argv, this is important for this program, but since it passes here argc and argv, I'm gonna show you how we can do it. First, import system.directory, I think. First, prog name, get program name. No, it's wrong. It's system.environment. Okay, now it's get prog name and args, get args. And instead of nothing, we can pass just prog name appended to args. Yeah, because argv in C, the first argument of argv is the prog name. So we gotta do it this way if you wanna pass it. Okay. G-object unref, we don't need this because we're in Haskell. We don't have dynamic allocation. We just gotta return status. Status is this, which I forgot. We can just go like status. Nice. And return status, no. To return an error code, we got import system.exit. We already did it. So exit with, and now if status equals 0, then exit success, else exit failure with error code status. Okay. No? What? Okay. Status is a int32. We need just an int. So we need to convert it to an int. Nice. Now it's an int. So the main function is ready. Now let's do the activate function. Window. Okay. equals do window takes a gtk application new. So gtk dot application new. No, gtk application window new application window new app. What's wrong? Okay, it must be an expression. Undefined. Yeah, no error. No, gtk window set title. Let's see what the readme says about it. Set. We have like b set and the name of the property. So the name of the attribute actually. So it's window set, and let's set what? Title. Window. Right? Right? Oh, okay. It's window title. It's gtk dot window title. Nice, okay. Yeah, gtk dot window title. And here we created grid. So grid gtk dot grid new grid set what? Set child. So set no, it's actually window. It's window here. Window. Our grid. Yeah, this took a bit of work, but I found the solution to this in this GitHub, thanks to Hamishmak. Here it is set container child, so it's not actually window, it's container. Container, yeah. So yeah, set container child because grid is a container. Okay, we were here. Set child. Now let's create a button. Button. GTK button new with label. It's GTK dot button new with label, and it takes text. Text, we can just use a standard string because we are using overloaded strings. So what's the text of the button? It's button 1. Oh, button 1. Just signal connect. It's button clicked, so it's on. Button clicked, and a callback function which is print hello. Print hello is this function here, but it's just a gprint hello world, and gprint just prints to the terminal, so you can just use put string line, put strlen hello world, right? Wait, oh, we have to pass the button here, button. Oh, it's gtk dot on button clicked. Okay, nice. At this point, I hope you got the idea about how to translate C API calls to Haskell GI. But there's a little problem. This approach is way too imperative. We are basically programming in C in Haskell. So how can we make this more declarative, more functional, that's where overloaded labels come in. If you look at the README file, you're gonna see this here. There's support for overloaded labels extension, so the examples above can be shortened to this. And this is way prettier than what we are doing. So what I'm gonna do now is pause translating this to refactor it using overloaded labels. So let's activate here overloaded labels. Okay, and let's start with the main. The main, we can see here, we can use the new syntax. The new syntax is just new, a type. Our type is application, and a list of attributes. So what's our list of attributes? And if you search for application in Google, here, Google, and search for application new, which was our function before the new keyword. Actually, new isn't a keyword, it's a function, okay? It's a function that takes a lot of things. But here we have the name of the attribute, application ID. So in the list of attributes, we can put hash application ID dot equals arg.gtk.example. Nice, which is this thing here. Also, we have the attribute flags. So we just pass hash flags here, and it's a list of application flags. So list, and inside the list we can have application flags, default flags. Okay, and nice. Now we can delete this, and okay, it already looks a lot better than before. But there's another thing we can do. This onApplicationActivateApp, we can use on inside the attribute list. We can do on hash activate and activate app. Yeah, but it doesn't work because app is a variable that doesn't exist in this context, because we are declaring the app variable here. So it isn't recursive, and that's a problem. But remember, this onApplicationActivate, if we search for it on Google, it had here a implicit parameter. It's the self implicit parameter. So we can use it to pass the app. We just have to enable here in the language pragma implicit params, and now instead of app we can pass question mark self, and now it works. See, it's the self implicit parameter, very useful. And now we can also delete this line. Application run. Application run, let's search for it on Google. Here, application run. We can see it has the label run. So instead of application run, we can just do hash run. Nice. It's a little shorter, but it's the same thing. Now our main function looks a lot cleaner. And let's clean the activate function a little bit. So the same thing, GTK application window new, we can just do new GTK application window, I think. right? Yeah, okay. Now let's search on Google. Here, application window, new. Here, application window new. It has the application attribute. So let's put here hash application equals app. It should work. Yeah, it works. We have also window set, window title. The title is also an attribute, so we can pass here hash title window, right? Yeah, now get rid of this line. Great. Let's do the same thing with grid. It's new gi-gtk grid empty attribute list. But now that's the interesting part. We have window set container child equals grid. What we can do is, instead of passing the child here, we can also pass it on the attribute list. We can go like hash child and grid. But grid doesn't exist yet, so we have to put this below the grid declaration, like this. Yeah. And now we don't need this line. See how it looks better? Let's create a new button. It's new gi-gtk button and hash label bang. And you can also do on clicked. On clicked, we call this function put strlen hello world. Nice, we get rid of this line. And see, now, oh, let me put back undefined. Now our code looks a lot cleaner, more declarative, more functional. Now, if you want your code to look even better, you can just align some symbols here, like this with align regexp. Nice, and we can also get rid of LambdaCase, because we got rid of that lambda, we don't need it anymore. And oh, I forgot to say, what is application activate callback? If you search for it on Google, you'll see it's just a type alias for the IO monad. So you can just use IO here if you want to. I'll just leave as application activate callbacks. Now I'll just keep translating this example tutorial here, and if I find anything interesting, I'll come back to say some words. I finished translating the app from the tutorial, and I indeed found something interesting. The last line of the function activate is gi-gtk widget show, and I translated it as hash show window. And if I try to compile this code, let's open a terminal real quick. Yeah. Cabal run. It shows the window, but just the window, not its childs, not its button and grid. So I searched on the web and I found the official documentation for gi-gtk widget show, and it says any widget that isn't shown will not appear on the screen. If you want to show all the widgets in a container, it's easier to call gi-gtk widget showAll on the container. So if we want to show the window and all its childs, we should use showAll. Now if I compile this, now the window widgets are shown. And it's working. If I press button 1, it prints hello world. I have to put focus on Emacs because it's lazy. I press button 2, and again, hello world, button 1, 2, 1, and it keeps going, and when I press quit, it quits. Now, what more can we do here? Let's refactor a little more. This thing here is way too ugly. Let's start refactoring it with, instead of rog name and args, let's put argv is lift a2 from control.applicative, and let's lift this with get prog name and get args. Okay, let's just import it. What this does is basically call get prog name, call get args, and apply this operation in the result of these two functions. And now we can pass here just argv. Okay. Now this line, instead of all this, let's use when from control.monad. Yeah. And now, when status is different from 0, let's exit with this. Here. Nice. And we don't need exit success because it's the default. So we'll leave just this. Also, in Haskell, it's not a good practice to have multiple labels with the same name. So I'm gonna call this button 1. Put here button 1. Button 2. This one is button quit. Okay. The last thing is here. Since we are using the application default flags, we can just omit this and it's gonna work the same way, like this. Okay, yeah, it works the same way. I pressed the button twice. Here are two hello world. Let's make this window smaller, just to make it look like the tutorial, like this image here. That's our grid, but I'm using a theme, so the default colors are different, but it's the same. Yeah, so that's it. You can see the Haskell code looks a lot cleaner than the C version here. And I hope you make great things with GTK. Bye.